This is our headquarters, the Senai Institute for Advanced Materials. We are located in São Bernardo in São Paulo. This is our campus. And soon we will receive other innovation institutes. This is already in transformation, and we are going to become a technological district. We have advanced manufacturing, biotechnology, and we are structuring all the Senai Innovation Institutes for technologic development. So this is going to be a huge hub. My goal is to have about 15 Innovation Senai Institutes collaborating in projects. We are currently an MROP unit, so we are active with the industry, supporting their needs, new developments, and bringing innovation. So we have work fronts in composites, light structures, applied chemistry, and I focus on nanomaterials. We always work with the composite teams. So in the previous presentation, we saw an explanation about graphene, which is helpful for me. I don't know if you were in the previous presentation, but there was an explanation on graphene. Well, let me just give you an overview. It's a three-dimensional, it's a big two-dimensional crystal formed by carbon, and it has a honeycomb shape. So let me tell you a little bit about the discovery of graphene. That's when graphene was isolated and it was verified that there was one single carbon layer. That happened in 2004, and the two researchers received a Nobel Prize for that discovery. So what is the difference of a nanoscale? In this slide, you see the difference of a nanoscale material. The basic difference of nanoscale is the presentation. We have surface volume area, and this structure, the central structure, if you can see it, it clearly shows the relationship between size and surface area. When we manage to go into nanometric structure, so we're talking about atoms here. That's the layout that we have to increase reactivity. So this displays in the thickness of each layer of graphene. This is important for different applications. To develop sensors, catalyzers, detection, hydrogen storage. So this very small thickness with a carbon atom, it makes it a great thermal conductor, 10 times more than copper, 200 stronger than steel. It is transparent. It absorbs 2% of light. It's a light material with, well, 1 gram of graphene can cover the size of a football field. So there are many advantages to graphene, but there are huge challenges as well, as we've seen. What are the methods to obtain graphene? I have selected 4 methods, such as micromechanical cleavage. This is inspired by the separation or isolation between graphene and graphite. From this mechanical exfoliation, we have chemical synthesis as well. There's a lot of room for evolution here. Synthesis from chemical reaction. which allows you, for this to be feasible, it still has a very high cost. Then we have steam, so you can use methane, for instance. Methane, you need a metallic substrate to work with the graphene layers. And a challenge is to remove the graphene layers so that they can be used. And small scale production is also a challenge. So, thinking of industrial applications, this is one that still has to be developed. Chemical exfoliation of graphene, well, we use in our institute, we do this kind of synthesis. So we start with graphite, and from oxidant agents, we can then exfoliate the graphene layers. So we can use potassium manganate, sulfur acid, and that allows you to place this between the graphite layers as to separate it into different sheets. And we obtain with that graphene oxides. These groups, they still remain in the structure because this can be positive for the applications as we mentioned in the previous presentation. Some segments in the market, these are products that are already being traded. Tennis rackets, paints, bicycle equipment, printing filaments. We already have materials like these, as you saw in the previous presentation. Some companies are already consolidated in the market, and here in Brazil, in our institute, there is a lot of search to develop materials with graphene. We have projects in the areas of paints, polymer, composites, projects that have the goal of giving scale to graphene production. Here you see the graphene global market. And the highlight are composites. And we also see the challenges here. As for composites, there are devices that sparkle a lot of interest. Graphene has huge mechanical strength, it is light, it is transparent, so it sparkles interest in several industries. Electronic device, biomaterials, membranes, sports materials, aerospace industry, auto industry. Different industries are looking for graphene. And at the Advanced Materials Institute at Senai, we can meet all these demands.